Welcome back. Thank you for coming back here. I do appreciate you joining me. So here's a little fist bump for you. Today's lesson is going to focus on converting a quadratic from standard form, and we're going to move it into factored form. So this is going to be the last of the three forms that we discuss. This is a skill that seems to show up over and over and over, so all through your future math life, you're probably going to have to know how to factor. So let's go ahead and get really good at it. First example, we are going to convert the following from standard form into factored form. You're going to do this by a process called factoring. So there's a couple different ways that some teachers might show this. Some of you might have been shown like this little diamond method. I don't do the diamond method. All I do is I simply look for two numbers that multiply to C, so they have to multiply to a 26, and they have to add or subtract to B. So in this case, they'll have to add or subtract to a positive 11. So in order to do that, what I do is I start with that 26, and I list out all the things that could possibly multiply and make a 26. And to me, that would be 1 and 26, or it could be 2 and 13. Now I have to find the combination of those that could somehow add or subtract to make this positive 11. So if I look at 1 and 26, if I add them, I get 27. If I subtract them, I could make a 25, but that's not going to make an 11. So let's get rid of that one. Now I look at the 2 and 13. That one looks a little more promising. 2 and 13, I could add them and make 15, so that's not going to work. But if I subtract them, 13 minus 2 gives me an 11. That's the one that's going to work. So what I'm going to do here is to make it equal 11, I need a minus on that 2. And now I want to double check. If I take negative 2 plus 13, does it add to 11? Yes, you're saying yes. And if I multiply them, negative 2 times 13, does it multiply to negative 26? And you're already saying yes. Good. So those are going to be the two numbers that I have. So now we just write a binomial of it. So your factored form would be f of x equals x minus 2 and x plus 13. So the negative 2 just goes right here, and the plus 13 goes in here. And that's all you have to do. It's now converted, and it is now in factored form. You could, if you're really unsure, you could double check your work by distributing. So you could take x times x is x squared. X times 13 is 13x. Negative 2 times x is minus 2x. And negative 2 times 13 is negative 26. And if you combine 13x and minus 2x, it does give you the 11x that we had originally. So that's one way that you could check your answer. Hopefully we get good enough at this where we don't even have to check our answer. Most of the times you're going to be able to do these in your head. But for now, we're going to show our work just so we can practice getting the process down. Next example, I want to find two numbers that multiply to a 30. So that could be 1 and 30. Or it could be 2 and 15. It could be 3 and 10. Or it could be 5 and 6. And if I want to find the combination that adds or subtracts to a negative 11, it won't be that one. 2 and 15 could make 17. If you subtract, it makes 13. It won't be that. 3 and 10 could make 13. If you subtract them, it could make 7. It won't be that. But 5 and 6, if you add 5 and 6, you get a positive 11. That's the one that we're going to be looking at. The problem is, I don't want it to make positive 11x. I need it to make negative 11x. So how could we do that? Just make them both negative. So negative 5 minus 6, that does give you a minus 11. That's good. And if I multiply them, negative 5 times negative 6, it does equal a positive 30. So the combination we're going to have is minus 5 and minus 6. Write your final answer as f of x equals x minus 5 and x minus 6. So we've taken a trinomial and factored it into two binomials. And one more example. We'll start by listing out all of the things that could multiply to a 42. and that would be 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work, but if you have 6, it can go with the 7. And we have to find the combination that adds or subtracts to, in this case, negative 1x. So that negative x just means negative 1. 1 and 42, that won't work because that's 43 or 41. 2 and 21, nope. 3 and 14, But 6 and 7, that one will work. So if I want to make this equal a negative 1, then I need the negative sign on the 7, because 6 minus 7 is a negative 1, and if I multiply 6 times negative 7, it equals negative 42. So there's my combination, and it's going to be f of x equals x plus 6 times x minus 7, and that is your factored form. So go ahead and give it a shot on the next 6. You know the drill by now. Go ahead and pause the video. When you are all done, come on back and I will reveal the answers to you. So go ahead and hit pause. Welcome back. How did you do? Oh, you did great. That's awesome to hear. What's that? You had a question? Oh, does it matter the order you put them in? If you look at x plus 6 and x plus 3, some of you might have written it differently. You might have had x plus 3 times x plus 6. It does not matter the order that you put them in. So either of these answers would have been correct. So go ahead and take a look at those. Check them off. Hopefully you got them all right. Now what we're going to do is we're going to move on to slightly more complicated ones. These are a little bit more difficult because the a value is not equal to 1 anymore. We're not just dealing with 1x squared, we're dealing with 2x squared or 6x squared or something x squared. So factoring these are a little bit more difficult. It requires a little bit more guess and check, but hopefully we get the hang of it and it won't be so bad. Let's take a look at the first example. We have this 2x squared here, so because it's a 2, it's going to be pretty easy. The only way that you could make a 2x squared using integers would be 2x and 1x. So I'm going to start by doing that. Next, what we're going to do is we're again going to look at this minus 21, and we're going to come up with numbers that multiply to a 21. And the only sets I can think of are 1 and 21 or 3 and 7. And we're still going to have them make an 11, but it's going to involve some multiplication in between. So let's go ahead and try this 1 and 21 first. So I'm going to start with a 1 here and a 21 here. And what we're going to be doing is we are going to be looking at the outside ones and the inside ones. We're going to see what happens when we multiply those and combine those. So let's start with the outside ones. 2x times 21 is 42x. And if I look at the inside ones, 1 times x, that's just going to be 1x. Now, could 42x and 1x, could those ever combine to make an 11 by adding or subtracting? No, you're shaking your head no at me. I can see it. So it's not going to be 1 and 21. So let's go ahead and switch it now. We'll change it to 21 over here and 1 over there. And we'll see what happens that time. 2x times 1, so if I do the outside ones, that's going to be 2x. And on the inside ones, 21 times x is 21x. Now, could a 2x and 21x ever make an 11x by adding or subtracting? You're shaking your head no at me again. You're kind of frustrated, aren't you? This isn't working out very well. So what we just found out is it's not going to be 1 and 21. So that combination, sorry, it's not that one. Now we're going to go ahead and try the 3 and the 7. So let's go ahead and try a 3 here, a 7 here, and see what happens. If I take the outside ones, 2x times 7, that's 14x. And if I take the inside ones, 3 times x is 3x. Could that somehow make a minus 11x? You're nodding your head at me. That's much better. You have a smile on your face. Great. To make a minus 11x, the minus sign would have to be on the 14. So negative 14x plus 3x, that gives you the minus 11x that we want. So in order to make it a minus 14x, the minus sign has to be attached to the 7, because 2x times minus 7 minus 14x. And we will have a plus sign in here, and this would be your final factored form, 2x plus 3 times x minus 7. So it does involve a little bit more guess and check, but eventually after you've done them enough, you kind of get the process down and you can kind of figure out which combinations they are a little bit more quickly. Next one. This one's going to be a little bit more difficult because that first term is 6x squared. So again, we'll make our sets of binomials. And you could do 6x and x. And the combinations of numbers that we're going to try are 1 and 20, or 2 and 10, or 4 and 5. And I'm going to give you a little spoiler alert. If you try 1 and 20, or 2 and 10, or 10 and 2, or 20 and 1, or 4 and 5, and 5 and 4, if you try it with 6x and 1x, you're not going to get the right answer. So let's go ahead and erase that 6x and 1x. And we'll try another possibility. And that other possibility that we have, erase, could be 2x and 3x. So when that leading term is a prime number, that's nice. You know, if it's like a 5 or a 7 and there's only one possibility, that's fun. When it becomes a number like 6 or 10 or 24, it becomes a little bit more tedious with more guessing and checking. Let's go ahead and try 2 and 10. So if I put a 2 here and a 10 here, and I look at the outside ones, that would become a 20x, and the inside ones, that would become a 6x. Could 20 and 6 make a 23? No. So it won't be 2 and 10. Let's go ahead and try the other way, 10 and 2. Check the outside ones, that's going to be 4x. The inside ones, that's going to be 30x. Could 4 and 30 somehow add or subtract to become 23? No. So let's try another one. We know it's not 2 and 10. Let's try 4 and 5. Try 4 and 5. If I take the outside ones, that's going to be 10x. If I take the inside ones, oh, we're so close. That's 12x. 10 and 12, that makes a 22 or a 2, but not a 23. So let's switch those around. Instead of 4 and 5, let's pick 5 and 4. Check the outside ones, that's going to be 8x. Check the inside ones, that's going to be 15x. Hooray! 8 and 15, that can make a 23. So in order to make this a negative 23, both of them have to be negative. So if you take negative 8x minus a 15x, it would make a negative 23x. So since both have to be negative, we'll put a negative here and a negative here. And you can again double check your answers and distribute it all out, and it should equal what you started with at the beginning. So it does involve a lot of guess and check. I'm sorry for that, but hopefully you get really good at this process. And with the next video, we're going to show you the purpose of factoring. So what advantages does factoring have? Go ahead and try the next 4 on your own. Go ahead and pause the video, and then I'll reveal the answers in just a second. No, I'm serious. Go ahead and hit pause. Pause right there. Pause. Ta-da! There's your answers. Go ahead and check those. If you got them wrong, go ahead and maybe double check and distribute and see why you got them wrong. If you got them right, that's super. You're awesome at factoring. So join me next time as we discover the purpose of factoring and the advantages of factored form. See you then.